Hello and welcome back. If you remember, I asked you 8 questions on my first video on images and pre-images, but I will remind you the questions are all the same because these are like properties, and especially the ones involving pre-images are really useful to remember. The setting was as follows, if you don't remember. We had a function that goes from x to y, and a and b were subsets of x, and c and d were subsets of y. And our question was, and where f of a means the image of f, and like image of a under f, and f inverse of c means the pre-image of c under f. Anyway, the question was, there are these eight lines, and each line has two sides, the left-hand side and the right-hand side, and the question is, are these two the same? Or what is the relationship between these two in terms of equality, some kind of inclusion, or is there no relation between these things whatsoever? I'll still give you a few minutes, if you haven't already done so, to pause the video and have a go at it yourself. Okay, assuming you've had a go at it yourself, welcome back. And I'll tell you the answers. So, the first one is equality. The second one is an inclusion. The third one is an equality. The fourth one is an equality. And this one is an inclusion in this direction, that's an equality. This one is an inclusion in this direction, and that is an inclusion in that direction. You can feel free to prove any of these if you want to do so, and I highly recommend you do so. And if you get stuck, I have made a separate video on proving these two properties, and once you know how to do those, you will see that proving all these properties is the same technique. So do have a look at these two videos, and that should give you an idea on how to prove these things. What I'm going to do on this video is make an observation. You know, any property that only involves pre-images, you see that it's always an equality. So it's an informal statement, but I would like to say that pre-images are very well behaved, not very naughty, under set operations. So what it means is that if you can take intersection, unions, complements, set difference, and all sorts of set operations, and if you take the pre-image, they will be well behaved. So they will behave exactly the way you expect them to behave. And for the rest of this video, I'm going to give you some examples to tell why this one, and this one can't be an equality. Let's start with the first one. So we have f of a take away b contains f of a take away f of b. So you can come up with your own example if you like. And here's my example. Say our set X has 3 elements, A, B, C, and our set Y has 2 elements, so X, Y, and the map is A goes to X, B goes to Y, and C goes to X. And if your set A is the first 2 elements, and if your set B is the last 2 elements, B, C, then you will see that f of A, the image, is everything. The image of B is everything. because B gets mapped to Y and C gets mapped to X. So therefore, f of A take away f of B is empty set because you are removing all the elements. However, A take away B because the only element in A that's also in B is B, so we just have to remove that. That's just A. So therefore, f of A take away B is just one element set X. So these two are not the same. So there's a counterexample. I will have a look at two other properties 7 and 8, and tell you why there can't be equality. Property 7 was, you start with A, you look at this image, and then you look at this pre-image, so you pull it back. And the statement was, and the claim was, it's not an equality, but it contains A. So what could go wrong? Let's have a look. So you start with something, say you start with these two elements. And suppose these two elements get mapped here. The first two elements get mapped here. And the third element also gets mapped to the first element. However, the fourth one gets mapped to the other guy. Now, if your set A is just these two elements, what you will see is that if you take f of A, so I will just call this A. If you take f of A, you will just get this element, right? But now if you look at the pre-image, yes, all the elements in A gets mapped to that element, but you will see that there's one more element here that gets mapped to your original, like to your element. If you give them labels, and say A, B, C, D, and then X, Y, you will see that if you let your set A to be A, comma B, then f of A would be just be X. But now if you look at its pre-image, f inverse of f of A will just be everything that maps to X, but then it also contains C, A, B, C, so you have included one more element. And similarly, for the other one, the other property was f of f inverse of C. So you look at something in Y, you look at its pre-image, and then you look at its image, and you get something smaller. So this will be inside the C that you started with. And the way to see this is as follows. If you have any set that's not surjective, so in other words, on which there are some leftover elements that don't have anything that matters to them. Say we have something like this. Just call this A, B, then X, Y, Z. W, so only Y is mapped, so X, Z, and W, they are not in the image of anything that comes from our set. So if you look at, say, let our C be, say, X, comma Y. So what happens is that if you look at its pre-image, then these are those elements of X that map to X or Y. So F inverse of C, but the only guys that map to X or Y are just A and B, both of them map to Y. However, now if you look at the image of this guy, then only Y gets picked up. F of the inverse of C, it's just Y. So what this does is that if our function isn't surjective, so that means there are some leftover elements, then it only picks up those elements that are in the image. So this can't be equal. I will just go back and make one more remark. If our function is, if f is surjective, so being surjective means so like every element in Y is hit by some elements in X. So It's like onto or surjective. Those are the terms that you might have come across, which just means everything is hit. If F is surjective, then last property is an equality. Then the property 8 is an equality. So these are the properties. Hope you enjoyed this video. I will try to use these properties in the future. So yeah, and if you don't remember, then I will refer you back to this video in the future. I'll just say bye for now. I look forward to seeing you in the future video.